Okay, Assalamualaikum and hello everyone. So for today's video, we are going to do the graph plotting after you've done your experiment and you have got your data for x and y axis. So basically for the graph plotting, our aim is to get the gradient of the graph. So let's look at how we plot the graph. We have a few things that you need to obey when you plot the graph. So you can refer to this table. We have scale, size, plot, labeling, centroid, best fit, and gradient. Okay, for the first step is to focus on the scale and also the labeling. Okay, for the labeling, we have to have the title of the graph. Okay, you have to write down it on top of the graph, and you have to have the symbol and unit. Okay, so for x-axis, okay, you have the symbol L for length and the unit is cm. So I'm using the data from this table. Okay, it is y versus x, time versus length, and for the t or the time it is for y-axis. And for scale, okay, for the scale, we actually have a few conditions that you're supposed to obey. That is, it must be for 1 bots. This is what we define as 1 bots. So the scale must be either 1, 2, 5, or the multiplication of it. For example, like 10, 20, 500. And you are not allowed to use the scale of 3 for 1 box. For example, 3, 6, 9. No, you are not allowed to do so. For example, for this data we use, okay, the suitable scale here is for y-axis we use the scale of 5, okay, and for x-axis we use the scale of 10. Okay, so when you plan or when you want to decide which scale is suitable, okay, you have to look at your smallest value and highest value for x, and also smallest value and highest value for y. Then you can have a good scale or a good range where to put your minimum value and maximum value for x and also for y-axis. Okay, the next thing to consider is the size of your graph. So this is really important. So how can we determine the size of our graph? First, it is depending on our graph paper. So if we refer to the y-axis, we need to count how many boxes we have for y-axis. So it's here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for y-axis or for vertical part of the graph paper, we have 10 boxes. Okay, so it means here that your size of the graph must be 50%, more than 50%, meaning that the size of the graph must be more than 50% of 10 boxes. So it means here that we have to have at least the size of the graph paper is more than 5 boxes. So how can we determine the size? Is to refer the first point or the lowest point. The lowest value is going to be the lowest point on the graph, and also the highest point or the highest value. Okay, so the size between 19 and 37.5 supposed to be more than 5 boxes. Okay, so let's say with the scale I've drawn here, or I've decided here, let's say, okay, I have this lowest point and highest point. Okay, and let us count how many boxes it takes from the lowest to the highest. So it's kind of 3.5 boxes. So it looks like 3.5 boxes, which means that it does not obey the size. Alright, since the amount of boxes is not exceeding 5 boxes, meaning that we need to have a bigger scale for y-axis. So then we can expand, or we can have a better position for lowest and highest point of uh, the reading. Okay, so if we refer the left side of this graph, we have of the scale for y-axis, we have the scale of 5. So we start with 5 and we end with 45 with a gap 5 for every boxes. Okay, since with this scale it cannot obey the size of the graph, so we're supposed to have a better scale. So what does it mean by better scale is we need to expand the scale. So just now we start with 5, but this time we have the scale 5 or the gap 5 will take for 2 boxes instead of only 1 boxes from the previous graph. Okay, so now I've changed the scale. So from this new scale, okay, from this new scale, so we have here the lowest point and this is the highest point. So if we count the boxes, it's 1 2 3 4 5 6 7. It is more or less 7, so 7 boxes. So this one is now obeying the size of the graph that is supposed to be more than 5 boxes. If we focus on this graph, okay, if we refer to this graph, we have kind of a weird look here. So it is the meaning that the axis is shrink, okay, because we didn't start, okay, we're not starting from 0. The reading is not started from 0, so we need to shrink. So it's 0 here, and then it's supposed to be 10. It's supposed to start with 10, but as we want to obey the scale or the value of the table or the data, so we need to start from 20. And from 20 we start with the gap 10, 20 until we get the maximum value. It's 90. Okay, and then now I plot the graph. So we have the marks for plotting. Okay, I plot the point. I plot the point. So all 8 points you have to put it at the right position or at the right coordinate. Okay, and also I need to put the centroid. So the way we draw the centroid is cross, and then you have to have a circle outside the cross, or the cross is inside the circle. Okay, let us proceed with the graph plotting. So we've done the scale, we've done the size of the graph, we've done the labeling, the plot. The plot is points, okay, points plotting, and we've done the centroid. So we have 2 more, that is we want to look at the best fit line and also the gradient of the graph. Okay, the best fit line is really important because it is going to determine your final value, or the value for the gradient is good or not. We already have the points plotted, okay, the black crosses here, and now we want to have a best fit. So the red line here is the best fit. So how do I determine this best fit is, okay, you have to take a ruler. Okay, you have to take a ruler. Then you place your line must be, first it must passes through, okay, this is compulsory, must passes through a centroid and at least 1 point. Okay, 1 point that is other than centroid. Okay, 1 point. So in this case, the data is not quite good because when we try to balance it, okay, the best fit must be balanced. Okay, the keyword here is balanced. So we only have 1 point. Actually, the more the point you have on the best fit line, the better the value, the better the value you will get for your gradient. So in this case, the line that I have tried my best to get the best fit is to be passes through the centroid, and this point. Okay, so we have 2 points here. So how do I know this is the best fit? Okay, so this is the where we need to consider the word balanced. Okay, balance means, okay, this is your centroid. So if you refer all the points below the level of the centroid, okay, all points here is 4 points. Okay, on the left side of this best fit, okay, the points on the left side, this one, these two, sorry, and the right side, the amount of the point must be the same. So here is 2 points that the line does not pass through, and we have 2 here. So 2 is balanced. Okay, and also you have to look at the upper level above the centroid. So here we have 1 on the left, this one is left, this one is on the right. So 1 on the left, and we have 2 on the right. So 1, 2. So 1, 2 balanced, 2, 2 balanced. But if you have, for example, 4, 0, it is not balanced. So that is how we determine the balanced best fit. Okay. So far this is the best fit that I can have for this data or for this graph. And last one is to get the gradient. So to get the gradient is, we need to have a triangle here. Okay, triangle with dotted line. So the size of the triangle, okay, so this is the graph. So if you're talking about the triangle, so the size of this triangle, inside this triangle, you're supposed to have at least 4 boxes. So I've drawn my triangle here. Okay, this is my triangle. So inside my triangle, I have here far more than 4 boxes, 15 complete boxes. So it is obeying what's supposed to be done. So the size of the triangle is supposed to have more than 4 boxes. You have to obey that one. Okay, once you have got your triangle, then you can calculate your gradient. Okay, so using the formula that I have taught you, so we have, here is the position for y2, x2, and here is the position for y1, x1. So the gradient is y2 minus y1 over x2 minus x1. Okay, so that's all for graph plotting. I hope you can understand what I have delivered. So if you have any questions, you can put it on the comment, or you can directly ask me during the lab session. Okay, thank you.